So I told you before about the split between theoretical and experimental mathematics. And right now, most mathematics is theoretical and only a tiny bit is experimental. I think the platform that Lean and other software tools, GitHub and things like that, they will allow experimental mathematics to scale up to a much greater degree than we can do now. So right now, if you want to do any mathematical exploration of some mathematical pattern or something, you need some code to write out the pattern. And I mean, sometimes there are some computer algebra packages that can help, but often it's just one mathematician coding lots and lots of Python or whatever. And because coding is such an error-prone activity, it's not practical to allow other people to collaborate with you on writing modules for your code, because if one of the modules has a bug in it, the whole thing is unreliable. So you get these bespoke spaghetti code written by not professional programmers, but by mathematicians, and they're clunky and slow, and so because of that, it's hard to really mass produce experimental results. But I think with Lean, so I'm already starting some projects where we are not just experimenting with data, but experimenting with proofs. So I have this project called the Equational Theories Project. Basically, we generated about 22 million little problems in abstract algebra. Maybe I should back up and tell you what the project is. Okay, so abstract algebra studies operations like multiplication and addition and their abstract properties. Okay, so multiplication, for example, is commutative. X times y is always y times x, at least for numbers. And it's also associative. X times y times z is the same as x times y times z. These operations obey some laws and they don't obey others. For example, x times x is not always equal to x. So that law is not always true. So given any operation, it obeys some laws and not others. And so we generated about 4,000 of these possible laws of algebra that certain operations can satisfy. And our question is, which laws imply which other ones? So for example, does commutativity imply associativity? And the answer is no, because it turns out you can describe an operation which obeys the commutative law but doesn't obey the associative law. So by producing an example, you can show that commutativity does not imply associativity. But some other laws do imply other laws by substitution and so forth. And you can write down some algebraic proof. So we look at all the pairs between these 4,000 laws, and there's about 22 million of these pairs. And for each pair, we ask, does this law imply this law? If so, give a proof. If not, give a counterexample. Mm-hmm. So 22 million problems, each one of which you could give to an undergraduate algebra student, and they had a decent chance of solving the problem. Although there are a few, of these 22 million, there are like 100 or so that are really quite hard. Okay, but a lot are easy. And the project was just to work out, to determine the entire graph, like which ones imply which other ones.
That's an incredible project, by the way. Such a good idea, such a good test of the very thing we've been talking about at a scale that's remarkable.
Yeah, so it would not have been feasible. The state of the art in the literature was 15 equations and sort of how they imply. That's sort of at the limit of what a human with pen and paper can do. So you need to scale it up. So you need to crowdsource, but you also need to trust all the. No one person can check 22 million of these proofs. You need it to be computerized, and so it only became possible with Lean. We were hoping to use a lot of AI as well. So the project is almost complete. So of these 22 million, all but 2 have been settled.
Wow.
And and of those 2, we have a pen and paper proof of the 2, and we're formalizing it. In fact, this morning I was working on finishing it. So we're almost done on this.
It's incredible.
It's fantastic.
How many people were able to get?
About 50. Which in mathematics is considered a huge number.
It's a huge number. That's crazy.
Yeah. So we're going to have a paper with 50 authors and a big appendix of who contributed what.
Here's an interesting question, not to maybe speak even more generally about it. When you have this pool of people, is there a way to organize the contributions by level of expertise of the people, of the contributors? Now, okay, I'm asking you a lot of pothead questions here, but I'm imagining a bunch of humans and maybe in the future some AIs.
Yeah.
Can there be like an ELO rating type of situation where like a gamification of this?
The beauty of these Lean projects is that automatically you get all this data. So like everything's uploaded to this GitHub, and GitHub tracks who contributed what. So you could generate statistics from at any later point in time.